Hi, everybody. Welcome to another Chats with Chaudhry. I hope you're safe and well. Today, I've got a returning guest at Chats with Chaudhry. I'm delighted to join by Chris Adams, who is the Business Development Director at Global Bioinformatics for Life Science Mass Spectrometry at Bruker Daltonics. And for those who will remember, Chris and I did a Chats with Chaudhry this time last year, in fact, at the launch of the PASER, which stands for Parallel Database Search Engine in Real Time, which is a bit of a long-winded title, if ever, hence why they're calling it PASER. So a year's gone by, and it's time to get an update because there's loads of new updates on the PASER. So Chris is kindly taking some time out to talk to me about that. So Chris, first of all, how are you, my friend?
I'm very good. Thank you, Rizwan. It's good to see you again as well. And I appreciate your background there. I am a Dodgers fan, a lifelong Dodgers fan. So
Yeah, well, actually, yeah. Well, I put it up especially for you, Chris. Although I do follow Dodgers, I stayed up to watch the World Series last year, so I was very happy to see them win. But I obviously is a bit nervous now. They spent all this money on all these players, but the Giants aren't going away, are they? They're still top.
no, they are not. They are not. Your favorite color fits the Giants better than it does fit the Dodgers.
It does, but I am a Dodgers fan, I have to say. So there you go. I don't pick all my teams for the color, it has to be said. So there you go. Okay. Anyway, look. So we spoke about PACE when you launched it last year. So I think it'd be quite good to get an update. But before we do that, for those who are not familiar with you and with Bruker Daltonics, would you mind giving a very quick overview of your own background and also about Bruker Daltonics?
Right. So thank you for giving me my title. I'm the Director of Global Business Development for the Bioinformatics side. Bruker is a very international company. We have multiple divisions. I'm within the Daltonics division, which represents the mass spectrometry equipment, right? So we have a whole series of proteomics, all omics, metabolomics, lipidomics, imaging, and other capabilities. And what I'm talking about specifically today in context of PASER is within the proteomics field.
Fantastic. So let's talk about PASER. So for those who are not familiar with PASER, let's have a quick overview. So what is PASER? Why did you launch it? And how can it help end users?
As you mentioned, it's parallel search in real time. So the brains behind this is GPU technology. So instead of searching across tens of cores, as would be the case with CPUs, we use GPUs to search across thousands of cores. And the result is that you effectively can search your data as the mass spectrometer is acquiring it in real time. So as soon as your LCMS run is done, you have data in hand. So that's why we aptly name it run and done. PASER, run and done. And it's a little bit more than that as well. So in addition to getting instantaneous results, you also can use those results to decide how you want the foregoing acquisition to proceed. So if some kind of QC, some kind of quality control metric is not met, then the acquisition would then stop. That information is relayed back to the queue to tell the instrument we're not ready to go. So, yeah.
Right. Okay. So you've had it out now for a year. So what has, and it's been out there live, being used in the lab. So what's been the feedback from those end users? And, what sort of interesting findings have you had from them?
Right. The feedback has been pretty fantastic. We've tried to go out, reach out, to every single early adopter, and what we found from those users now of PASER is really where it's most helpful is in method development. So whatever they're doing in terms of an enrichment or some new digest, what have you, they get the information in real time is so valuable for them to decide how they should continue with their experiments. They don't have to wait until the next day or days or what have you. They know in real time exactly what they need to do to tweak their method to get optimal results. And additionally, one thing what we've learned too, and we're really going to build this out, is, as I mentioned before, the quality control part of this. So defining those QC metrics, how those look longitudinally across many hundreds of runs is really critical to the researchers that we've been talking with. And the final thing that I might note is what we've seen with the adopters of the timsTOF technology is many of them appreciate the extremely fast scan speed that it affords you for data-dependent acquisition. But a lot of them are also moving over to another acquisition type called data independent acquisition. So instead of rather randomly or stochastically picking peptides, they're very methodically going across the mass to charge window in combination with the ion mobility window to get reproducible, what we call low missingness data in the DIA PASEF context. So, we're also trying to accommodate the capabilities of PaSER to those that are doing DDA or DIA PASEF.
Right. So you're talking about a shift in the way some of the proteomic researchers are using instrumentation. So what does that mean then in terms of the data analysis?
So what it means is that we need to be extremely flexible and creative as to how we accommodate the needs of our customers. So as I mentioned, DIA PASEF has become a staple for a lot of those users. So we're actively working on an integrated data independent workflow as well.
Right, fantastic. And so have you added any other new features to PaSER since it was launched a year ago?
Yeah, in fact, we have. So, I'll highlight three in addition to the integrated DIA workflow. So, we've been working with BSI. It's another software company specializing in proteomics software. Them in combination with Tony Purcell's lab at Monash University. So Tony's really interested in immunopeptidomics, and part of that requires very computationally intensive database searching because you do it de novo. So you don't use a database at all. In fact, you sequence those peptides using de novo analysis. And fortunately, BSI has already a GPU-enabled de novo search algorithm, and that's called Deep Novo. So what we've done is we've onboarded that Deep Novo algorithm onto the PaSER box so that as the information from the mass spectrometer relays into the PaSER box, it's also fed into this Deep Novo algorithm, and that provides us real-time de novo sequence capabilities, which is extremely powerful, as you can imagine.
Yeah, well, forgive my ignorance. Can I stop you there 1 second? Because so when you say de novo, though, so how does that differ then from other ways of processing data?
Right. So it differs because now you've gone away from relying on a database, right, as to what you're searching against. You're actually mining the spectra one by one by the features within those spectra.
Right. Okay. Sorry. I interrupted you.
No problem.
You continue. I interrupted your flow then. But
no, I appreciate the cadence and the questions, because I'm sure if you have questions, then the potential listeners will as well.
Fantastic.
So what I also want to say is we have another feature called timsviz. Right. One of the unique capabilities with timsTOF Pro Data is that you have this mobility offset mass aligned events. So often cases, especially as we push towards translational capabilities, we get to shorter and shorter gradients and more, the samples are complex. So more things are going to come out in a shorter amount of time. And that often results in interference. So whatever the tolerances of a quadrupole can handle, you'll get interfering species. But if those species have the same molecular weight but a different mobility, we can now resolve those. And our software team has been working diligently to build this software tool called timsviz, which allows you to visualize those events. So mobility offset mass aligned visualization, and it's really a beautiful feature that I'm very proud to see that PaSER team have enabled. And the last thing that I would mention would be TIM's score. So we're also working with John Yates and Robin Park, who came from John's lab, is now the director of bioinformatics for Bruker, and one of the talented grad students in John's lab, Ty Garrett. And what they've done is they've taken machine learning capabilities, process many hundreds of thousands of peptides, where now from the primary amino acid sequence, we can predict what the collisional cross-section value is. And now that we can predict it, we match it against the experimental value, and we use that in a database algorithm for database searching. So what it means is that we now identify more peptide spectral matches with a higher degree of confidence, so a lower false discovery rate. So yeah, so in essence, it's the first CCS-enabled database algorithm.
Brilliant. Well, machine learning has obviously been used more and more now in terms of searching databases and sort of analyzing different bits of data now in pharma, isn't it?
Absolutely, yes.
Right. So you mentioned you're working with these other groups. So does that mean now that the PaSER is flexible in working with other tools and instruments as well?
Yes, so we've really thought about this carefully, and one of the things that I'm really proud to say Bruker has done since the timsTOF release is that the data that you acquire on it is open access, sort of say. So it's basically a SQLite formatted data structure, and in building out PaSER, we really have taken an iterative approach with each update adding additional capabilities that those users can take advantage of. And moreover, I'll also say that the way we envision PaSER in its entire context is as a launching pad, really a launching pad for the creative researchers that have much more brilliant ideas than we have that they will think up for the next best processing or acquisition capability. And we really want PaSER to be able to enable them to do those things.
Well, that's really interesting you said. It was my last question was going to be, where do you see the future? What do you see the future hold for PaSER then in terms of looking ahead now and its development?
Right. So in addition to the things that I mentioned, we'll continue to work out and build in what the early adopters have told us is missing and most critical. And as I said, we're really driving towards third-party applications so that other people can incorporate their brilliant ideas onto the PaSER box.
Brilliant. And now, where can people get more information if they want to know more about PaSER, and also maybe see you guys? But I know lots of big events are coming up as well over the next couple of months.
We do. We have ASMS coming up, which is both a in-person and virtual conference. So I'm looking forward to that. And then immediately following ASMS will be HUPO. There'll be plenty of new information to be found there. Also, visit our website. We have a mypaser.com website dedicated strictly to PaSER. There's a FAQ section in there. There's a place to leave your comments. And additionally, Rizwan, one thing I would like to point out to you is, as I said, we've been talking to all the early PaSER adopters, but we also want to hear from the people who haven't adopted the technology, but are just general proteomics users. We have a questionnaire on that website, which I'll make sure I give you the link to. We'd really like to hear their feedback as to how this should be built out, what's most important for their scientific endeavors.
Brilliant. Okay, well, I'll make sure that link is above the video. So, Chris, thank you very much. It's lovely to see you again, a year on. And, last time the Dodgers hadn't won the World Series at that point, but they did go ahead to win it. So hopefully this is a lucky omen. We're doing this interview now before the playoffs start. And
I agree. And it was great to see you again, too, Rizwan.
It was lovely to see you, Chris. Well, look, I look forward to that. So thank you very much. So there you go, viewers. There's a quick update on what the PaSER has been doing over the last 12 months and the new updates for it. If you'd like to know more, then check out the links above the video, but also you can meet the Bruker team both virtually and now live if you're at ASMS and HUPO, because they will be there. And I know they've got quite a big booth at ASMS, I've been told, so you can check it out with lots of products being demonstrated. And also you can check out all the links. And as Chris said, it's always great to get feedback from people out there to improve the products which you're actually using. So if you've got any feedback or are prepared to give some feedback to Chris, then go to the link which will be above the video and fill in the questionnaire. I'm sure Chris will be only delighted to get your feedback to see how they can develop the product. So Chris, all this says is go Dodgers. Let's hope they win the World Series. I mean, unfortunately, I can't say go Dolphins or go Hurricanes, but they're doing terribly at the moment. So I can't really talk about football. I can talk about the baseball anyway, so that's good. So enjoy that. I hope you enjoy the World Series, and I hope you have a fantastic couple of shows which are coming up. And obviously, I hope the continued success for PaSEF. Thank you very much for your time.
Thank you.
And thank you, viewers. And until next time, as always, stay well and stay safe. Bye-bye.